Friends, today we will see the suspension bridge and components of suspension bridge. So you will be having one numerical based on the suspension cables and suspension bridge. So today we will see just only components of the suspension bridge and its working. Okay, so this is a typical sketch of the suspension bridge showing all the components. Generally, suspension bridge consists of two suspension cables along with number of suspenders, and these suspenders are connected to the roadway directly, or sometimes it is connected to the stiffening girder. Then this main suspension cable is supported over the towers, and to reduce the bending moment in the tower, an anchor cable is provided, and this anchor cable is inserted to the hard strata at the end of bridge. Now you can see this is your anchor cable, this is suspension cable, this is again anchor cable on the other side. These are the suspenders which are connected to this main suspension cable, and these suspenders are connected at the bottom to the actual roadway, or sometimes it is connected to the stiffening girder, and stiffening girder supports to the roadway. Okay, now how the load transport takes place in this case? See, suppose this is the vehicle on the roadway. So vehicle transfers the load to the roadway, then from roadway the load will be taken to the suspender, then suspender will transfer the load to the main suspension cable, and then with this cable will be transferred the load either to the cable will transfer the load to the main tower and anchor cable. Okay, this will be the actual load transfer in the suspension bridge. Now the main or very popular example of the suspension bridge is Lakshman Jhula at the Rishikesh. Okay, now see here at the tower where the main suspension cable is supported, there are two alternative arrangements to support the cable. So this is one arrangement where it is supported by the guided pulley support. So here it is pulley is connected. So this is your main suspension cable and this is anchor cable. So this is one type of support at the tower, and this is second type of support, and this support is called as roller pulley support. So here what happens, a roller is provided, and this is your suspension cable and this is your anchor cable. So these are the two different types of supports provided at this top of the roller. Now see here the cross section of suspension bridge is given, where these are two cables, two main suspension cable. These are the suspenders connected, and this is your main carriage way or roadway, main actual road. Now where we have to construct this suspension bridge only for the pedestrian. If you are constructing the suspension bridge only for the pedestrian, then you can connect the suspender directly to the roadway. But suppose you have to design or construct the suspension bridge for the heavy traffic movement, so in that case you have to provide a stiffening girder here. Now why? See, this suspension cable does not support or does not carry the bending moment. Okay, now due to this, if you apply a load over here, suppose this is a cable, and if you apply a load over here, what happens? Cable adjusts their shape to the load. This is your original shape. Due to application of load, it has adjusted its shape. So cable adjusts its shape as per the application of load, and it transfers the load, by tension only. It does not carry shear force, it does not carry bending moment. Okay, now due to this characteristic of the cable, what happens if I apply due to this suspender, this point load will be applied over here. Suppose this is the vehicle, or you can say any load over at the carriageway. Due to this load will be transferred directly to the suspender, and this suspender will transfer the load to the carriageway. And at this location, what will happen? Cable will change the shape, and as this cable has changed the shape, definitely the carriageway will also possess some deflection, lateral deflection. Now, due to this, a stiffness will not be given to the actual roadway. So, for pedestrian walking, for pedestrian movement, it is okay to transfer this load directly to the carriageway or to connect the suspender directly to the carriageway. But suppose for the heavy traffic movement, there should be some stiffness so that this road will not move or deflect laterally as well as longitudinally. So to provide a stiffness, a stiffening girder is provided. Now what is mean by girder? Girder is nothing but the beam with the large span. Now what happens in the girder? In case of girder, we provide a beam over here, a long beam supported by the tower. We provide at the bottom of the carriageway. Now what happens? How the load transfer takes place now? Here, this is, let us say, vehicle. This vehicle will transfer the load to this carriageway. From carriageway, the load will be transferred to the stiffening girder. Then stiffening girder will transfer the load to suspender. Then from suspender to cable, and cable from cable to tower as well as anchor cable. Now what happened? We have introduced the stiffening girder between the suspender and carriageway. Now this stiffening girder now provides the stiffness to the main carriageway. So vehicle movement or vehicle load will be transferred to the first stiffening girder, and from stiffening girder a uniform load will be transferred to the suspender, and from suspender to main cable. Now this stiffening girder provides stiffness to the suspension bridge or suspension cable, whereas cables reduces the bending moment, or the suspenders reduces the bending moment in the stiffening girder. Both are complementary to each other, stiffening girder as well as suspension cable. These are the suspenders. Suspenders will take the load in opposite direction. So what will happen? Definitely the bending moment from the stiffening girder will reduce, and due to the stiffening girder, overall stiffness of the bridge increases. So both are the advantage for the bridge. So this is how suspension bridge, also working of the suspension bridge takes place. Okay. So this is the cross section. These are the typical two types of support at the top of the tower, and this is the cross sectional view. A very good example of the suspension bridge is Lakshman Jula at Rishikesh. So we will solve some numericals also based on this suspension bridge in next lecture. Thank you.